Okay, I'm Dylan Simpson, part of the electrical program. For my project, I did a battery tester, battery capacity tester. Basically, you can put a double A in, a 9 volt or a 12 volt, and get a percentage of battery life out. Little background. I found one online that does a similar thing, but it only tests double A batteries. It goes through a FET, basically just measures difference in voltage, converts it into amp hours, and you get a reading. He used an Arduino and like a Nokia LCD, so I wanted to use our Freescale board and the LCD like we've used in class, just to be different. System diagram. Basically, I'm going to bring 5 volts of power in and put it to the Kinetis board. Then each battery is going to go through a transistor, get turned on, and go through an A to D converter in the Kinetis board. And the output is going to be read in the LCD. Obviously, the voltage of the 9 volt has to be brought down and then converted back through formulas in order to get an accurate reading and not blow out the board. So here's how the battery, the 9 volt battery is going to be tested. It's going to come in through a resistor off the Kinetis board, and it's going to go into a FET or transistor, whichever works really. And then it's going to be turned on, and the 9 volt is going to come in through a voltage divider to bring power down, like I said, which I have all the calculations. And then it's going to go through a voltage follower just to make the reading more accurate, and then into the A to D converter, D21s, and A to D converter pin. The 12 volts, the same thing really. I even use the same voltage divider, it's just going to be a higher voltage in, and the same voltage follower, which is an LM358. Basic calculations, I did the voltage dividers. You can see the 400K was where it actually went through, so 400K divided by the 2 meg plus the 400K times 9 would be at 1.8 volts into the Kinetis board. Same thing for the 12 volt, but it's obviously going to be higher, 2.4 volts into it to convert. And the LCD display, basically it's the same one we used in a previous class. So it's just a matter of finding the right pins and stuff. Ground, pin 1, obvious. The VCC, I had to find the right resistor to bring current down where it should be as an input. The data, you don't have to use all of them, so some of them are just grounded. The pot there is for adjusted contrast like the other boards, so you can see it up here. And the 11 through 14 are the data bits I'm going to use. 15 to 16 were my, as a backlight, I have a red LED backlight. And the current has to be brought down, that's not the actual value, but current has to, it's going to be like a 220 ohm to bring the current down for what a backlight should be. Board layout, basically the AA batteries here, 9 volts here, 12 volts here. And see the transistor here, it's going to be brought in. Now all of them for the voltage divider are here. This one's the B for the transistor. AA is simpler because lower voltage, I don't need to bring voltage down into the AV converter. LCD is going to be laid out so it sits up above, so when I make the final product, it's all easy to make, and the LCD is in a good spot. A couple push buttons, so if you want to choose the type of battery, you can, basically just for programming. Finished product similar to this, but obviously I only have one AA battery. The guy who made this wanted to have 3, just so you can test 3 at the same time. I'm going to use clip leads too for a 9 volt and 12 volt. It's all similar idea. LCD, mine's a 2x16 character, so it's going to be more rectangular and bigger. Issues I ran into, proper components like transistors, resistors, it had to be able to handle a higher current like I'm putting to it. So I wouldn't like a 2N222 transistor just because it can handle a higher current, which we had in stock. And the right resistors to break stuff down so I don't blow out the tennis court. And the proper pins, I looked into it and found out that there's different pins that can handle different voltages. So basically just using the right ones where I need to. And understanding the charge of batteries, you can't just take voltage and you can get a percentage. So it's just gonna be through formulas and code that I come up with the right percentage. Okay, societal impact. Less wasted batteries, because in some cases the battery doesn't work for what you're doing, but there's still plenty of life left. And you can use it in other applications until it's actually dead. Test batteries efficiently. It should use minimum current to actually test them with the resistor coming in the transistor. And knowledge of battery capacity before it's used, so somebody doesn't go off somewhere, I guess on a vacation or something with a camera, and have the batteries be more dead than they thought they were. Questions?
Can you go back to one of your circuit slides, and I think you might have explained it, but can you explain what you're gonna do in software? Or do you do that already? What are you gonna do with the transistor?
Measure voltage basically. Any example I found, you have to measure the voltage, almost a voltage difference, and then charge the battery up and then discharge it. And then you measure, you can convert into milliamp hours is the best way to do it. My software's not down with this.
But, okay, so, I think you just said it, but say it again. How many times are you gonna measure the voltage? And what's the transistor?
It'd be two,
Okay.
measure it twice, charge it up, measure it, and then bring it down over time, which would also be part of the formula.
This is not a charger, right? I mean, you're using, you're not necessarily
No,
recharging.
that's not charging it, no.
Yeah, okay. But you're measuring it, then you bring it down using the
Right,
transistor.
yeah, I guess the transistor, no, it doesn't charge it, it brings it down and measure voltage.
Yeah, and so you're expecting to see it drop at least a
Right.
little. And then we've gotta determine what the formula is,
Right,
convert that to
Yeah, yeah.
capacity.
bringing into account the curve of the battery, different type.
Okay. Any other questions? How far, you've got the board, right?
Yeah, the board.
And we just started to solder things on it?
Right.
Okay. And, the LCD is, you mentioned the backlight, right? So it's one of those red on the
Yeah, it's a
back.
red backlight. The back is actually lower curve, different colors. More efficient.
All right. Any other questions?